right, guys, we're going to look at our next exponent rule, which is a negative exponents. So remember when we divided, we were supposed to subtract those exponents. Now, not all the time when you subtract two numbers is that number going to end up being positive. Now, I made it to where that was always the case so that we could talk about these negative exponents a little bit later. So now I'm going to show you what happens when you have those negative exponents. So our exponent rule here that's going to be in our formula chart is going to be a to the n, or a to the negative n is equal to 1 divided by a to the positive n. So anytime you have a negative exponent, it's going to kind of flip the place. So if it's in the denominator and it's negative, it's going to go up to the numerator. And if it's in the numerator and negative, it's going to go down to the denominator. And that's when it becomes positive. So no negative. You don't want any negative exponents. So if you see a negative exponent, that's bad. Cut it out. So if you'll notice here in our example, we have 6x to the negative 7th. You'll notice that 6 stays on top because that negative 7 isn't applying to the 6. It's only applying to the x, which makes it move the base and the exponent, okay? So it's not like 6x stays up there and then just the little 7 exponent goes on the denominator. That's not how it works. So let's look here. I'm just going to rewrite this one simplified form because I don't want a negative exponent there. You'll see I have 16x to the 5th and then y to the negative 7th. So in order to make that negative 7 as an exponent positive, I'm going to move it down to the denominator. That negative 7 is only applying to this y right here. That's it. So that's the only thing that's going to move down. So I have 16x to the 5th divided by y to the 7th. And then that's all done. So I know, seems pretty simple. We're going to get a little bit more challenging here in a second. Example 2 here. So you'll notice that I have some negative coefficients and some negative exponents, and I'm multiplying. So remember when I multiply, I'm going to multiply the coefficients and then add the exponents. So I'm just going to go through there and do that one all the way through first. So I have 15 times negative 2 times x to the 5th times x to the 3rd, negative 5th. Sorry about that. And then I have times y to the 7th times y to the negative 3rd. So I'm going to go through there and just add those exponents and multiply the coefficients. So I still have negative 30. And just because a coefficient is negative does not mean it goes down to the denominator and makes positive. And then x, and have negative 5 plus 3, which is going to be a negative 2. And then I have a y, and we have 7 plus negative 3, which is actually stays a positive 4. Then I can't have negatives in there. So this at this step right here is kind of like the last problem over here where we have a negative exponent and we need to simplify that and make it positive by putting it in the denominator. So I have negative 30 and y to the 4th stay in the numerator because they don't have a negative exponent. And then x to the positive 2 because it goes down to the denominator there. So this would be the simplified form. I told you it's going to get a little tricky. Okay, so here you'll see we are going to divide here. And so remember when we divide the coefficients, and then we subtract the exponents, and then we'll have to kind of do some rearranging based on our, if we have any negatives. All right, so let's look here. We have 15 divided by 10. That's not going to be a nice, pretty number, and that's okay. And then I'm going to have x to the 3rd time divided by x to the 6th. So I'm kind of splitting these all up. You don't have to do this. I sometimes just think it's a little bit easier. And then I have z to the 12th and z to the 8th. So remember, I'm going to divide. So 15 doesn't divide evenly into 10, but I can reduce it. Remember that dividing is like the same thing as a fraction. So I can reduce that to 3 over 2. And then I have x to the negative 3. So remember, I'm going to subtract the two exponents. So I'm going to subtract 3 minus 6. So top minus bottom. Then I have y. I'm going to do negative 8 minus 2, which is going to be a negative 10. And then I have 12 minus 8, which is z to the positive 4th, because I have a bigger number in that numerator there. So now we are going to go back through and now simplify. So notice that my x has a negative exponent and my y has a negative exponent. So I have 3 in the numerator and z to the 4th. So this is a positive coefficient. A positive exponent. So it stays up top. Our x to the third and x to the negative third and y to the negative 10 is in the denominator with our 2, because that's 3 over 2. So divided by 2, x to the positive third, because it becomes positive when it moves, and then y to the positive 10th. So some things that you want to remember for negative exponents: they should switch from numerator to denominator and vice versa. So they either switch, if they're negative, then they're in the numerator, they go down to the denominator and become positive, and then vice versa. If it's negative in the denominator, then to make it positive, you move it up to the numerator. Remember that coefficients still follow the mathematical process. So remember that for a negative a negative coefficient does not mean that it automatically needs to become a fraction and go down to the denominator. You've been working with negative numbers for several years now. That's not how that works. Okay, so those still stay the same. Negative coefficients still stay the same. They stay in the numerator. Okay, and then we have our negative exponents is what makes those go down to the denominator there. So again, getting a little bit more challenging here. In the next couple of videos, we're going to start putting all of these together, and you guys got this.